Okay, so this is the test number 7. First question. Consider the physical quantities shown below. Electric charge, mass, and temperature. Fundamental physical quantities are. So out of these three, they are asking for fundamental physical quantities. So we know that mass and temperature are fundamental physical quantities. But if you think about electric charge, it is not a fundamental physical quantity. It is a derived physical quantity from electric current. Electric current is the fundamental physical quantity, not the electric charge. You have to remember that, because many students think that electric charge is the fundamental physical quantity. It is not a fundamental physical quantity, but electric current is the fundamental physical quantity. So the answer should be B and C. That is fourth answer for the first question. The second question. Resistive force, capital F, acting on a ball with radius r at velocity v is given by the equation. So the equation is given F equals K R V. Dimensions of K is, so they are asking for the dimensions of K. So as usual, you just have to do a dimension. So both sides of the equation have the same dimensions. So the dimensions of force is ml minus t minus 2. They are asking for the dimensions of K. This is the radius, so it is a length. This is a velocity, so dimension should be L2, L t minus 1. LL cancels off. Then M is here. Then if I take this L to that side, this becomes L minus 1. Then t minus 1, t minus 2, this becomes t minus 1. So this is the dimensions of K there. So the answer for that should be the third one, the dimensions of K. Third question. The scale of a millimeter that can be used to measure currents up to 30 milliampere is shown by the image. So we are given an image, the scale of a milliampere. When it is not connected to a circuit, pointer is shown. The choice that shows both zero error and least count in order is. So we have this scale here. This is scale of a millimeter. Value here 0. Then we have 10, 20, then 30. So those are the values. So in the question they say that when there's no current flowing through the millimeter, it has a reading. So without a current, the millimeter should not have a reading, but this millimeter has a reading, meaning that this millimeter is erroneous. So this reading, something like this. So we can say that this millimeter has a zero error. So without any physical quantity to measure, the measuring instrument shows a reading, which should be the zero error. So before finding the zero error, we consider the least count. Okay. So if you think about this, you don't have to think like all the 30 value, you can just think. So the value here is just 10. Then this 10th value is divided into 5 parts. 1, 2, 3, 4, 5. So if value 10, meaning 10 millimeter, is divided into 5 parts, least count should be the value of one part. So that 10 divided by 5. So it is 2 millimeters. So the value of one part is 2 millimeters. So that 2 millimeters should be the least count of this apparatus. 2 millimeters. It is not 1 millimeter. It is 2 millimeter. That is the least count. Okay. Then we can figure out the zero error. Zero error should be the value indicated here. So the pointer here is directed towards the third mark here. So that third mark, the value of the third mark should be 246. Okay, 246. So it should be 6 millimeter. So it is 6 millimeter. So this is the least count, that is 2 millimeter. Then zero error should be 6 millimeters. Then we have to check whether this is a positive zero error or negative zero error. So if you think about this measurement, let's say we take a measurement using this. So if you take a measurement, always to that measurement, this amount is always added. So we have to subtract this amount from any measurement we take. So the correction is negative there. So by definition, we can say that zero error is positive. If you remember, if the zero error is positive, then the correction should be negative. I mean, it should be a subtraction from any measurement. Okay, then the zero error is positive. Least count is 2 millimeters. So the answer to that should be fourth one for the third question. Moving to the fourth question. Pitch of a screw gauge is 1 millimeter and its circular scale is divided into 100 parts. Least count of the apparatus is. Okay, so screw gauge. So pitch means if you have a screw in that screw gauge, pitch means the length between these two. Then this length is called pitch. Then that value is given as 1 millimeter. Then they say that circular scale is divided into 100 parts. So in a screw gauge, how do you find the least count? We have this equation. Least count of a screw gauge is equal to pitch divided by number of parts divided in circular scale. So the pitch here is 1 millimeter. Then the number of parts divided is 100. So this should be 0.01 millimeter. Divided by 10, then again divide by 10. 0.01 millimeter. So that's the least count of this screw gauge. So the answer should be fourth one for that question. Okay, fifth question. A car reduces its velocity from 30 meters per second to 15 meters per second within 10 seconds under constant deceleration. It comes to rest after. So they are asking for the time for the car to be at rest. Initially it has a speed 30 meters per second, then it decreases its speed to 15 meters per second, and the time taken for that is 10 seconds. So what they ask is for the car to stop or car to halt, how much time does it require? Let's say that time is simple t. Time required is simple t. Then at here the velocity of the car should be 0 after the so before this I'm going to apply equations from here to here in order to find the deceleration. So let's say 1, 2, 3. So from 1 to 2 if I apply v equals u plus 18. So the final velocity 15, initial 13 plus a, time is 10. This is a minus 15, 10a. So a is minus 1.5 meters per square second. So this is the deceleration. So we just found the deceleration. So the car keeps having that deceleration after this as well. So we can use that in order to find this time. So to find this time, again, I'll apply the same equation but from 2 to 3. 2 to 3. So the final velocity here, the car stops 0. Initial here, that's 15 plus, but this is A is a minus, it is a deceleration, minus 1.5, then time t. 1.5 t, take this term to this side, 1.5 t equals 15. And t equals 15 or 1.5, which should be 10 seconds. So the time should be 10 seconds. Yeah, after 10 seconds, after the car it moves another 10 seconds, it stops. So the answer for that should be the second one for the fifth question. Next question. 6. On floor of a train moving at 30 meters per second, a passenger rolls a small ball at 16 meters per second to a perpendicular direction of the moving train. Velocity of the ball relative to Earth is. Yeah, so this is a relative motion question. They say that, let's say, train is moving to this side at 30 meters per second. If they say a train moves to 30 meters per second to this side, so it's a velocity that is relative to Earth. Okay. So this is train, let's say train is capital T. Relative to Earth, velocity of train is capital T. Then they say perpendicular direction of the moving train. So direction of moving train, they throw a small ball perpendicular to this direction inside the train. So this velocity, you have to remember that they don't always mention that, but you have to remember that. So that should be relative to the train. This velocity is relative to the train, not relative to Earth. So that velocity given as 16 meters per second. So this velocity V is relative to train. Velocity of the ball relative to train. Yeah. So what they ask is velocity of the ball relative to Earth. This velocity is relative to train, right? But what they ask is the velocity of ball relative to Earth. So just we'll apply this equation. Velocity of ball relative to Earth. So just put a t here in between. Then this becomes Vt plus Vte. So Bt, we have that value 16 to this side plus Vte, we have that value as well 30 to this side. So these are two perpendicular velocities. So we know we can easily find that using parallelogram law, but this is much easier than that. This is 30, 16, then the hypotenuse or the diagonal here shows the resultant of these two velocities, which is supposed to be the velocity of train relative to, velocity of ball relative to Earth. Okay, just have to find this value, so just apply Pythagoras theorem. So value of VBE should be 30 squared plus 16 squared, root of that. So this is 900 plus 256. Then we have 56, 11, 56. So that value should be 34. So this is the velocity of the ball relative to Earth, that is 34 meters per second. Okay. So we don't have to think this much. It takes time to explain, but if a student knows this is stuff, at once you can just jump into this one, right? You don't have to do all these, but it takes time to explain what really happens here. eighth question. A huge number of bullets is shot in all directions which initial velocity v, maximum area that will land on the ground is, that a bullet could land on the ground is. Okay. So they say like they have a gun, so the bullets can be shot, so the bullets would have projectile motions. So that gun can point to any direction. So the gun can point to any direction and fire its bullets, but the velocity for each instant is v. Velocity is just v. So they are asking for the maximum area that there's a possibility for those bullets to land. So if you remember the maximum distance that a bullet can fly, we have to find the maximum range. So to have the maximum range, you have to remember the angle to be projected should be 45 degrees. So let's find that first. So this should be 45 degrees, with the velocity is v. Then just find r max. So that r max value should be the radius there, r max. So any point within this area is, there's a possibility for a bullet to land. So out of this area there cannot be a bullet landing. So it should only be within this area. Okay, so you just have to find this area. First let's find r max value. So as usual, just apply ut plus half a d squared upwards. So vertical upwards goes up, then it comes down to the original position. So the vertical displacement is 0. Then v sine 45 is the vertical component, time plus half. Gravitational acceleration is downwards, so it is minus g d squared. D is cancels off, and this becomes half g equals v sine 45 means 1 over root 2. Then we have a t here, right? Then t is equal to 2v divided by root 2g. So this is the time. Again, further simplify this. So this becomes root 2 cancels off, and this becomes root 2 v divided by g. So this is the time that it takes for this projectile motion to have the maximum range. Then apply equations horizontally. S equals ut. Horizontally is r max. Horizontal component is v cos 45. Time is, we found root 2 v over g. V cos 45 is 1 over root 2. Root 2 v g. Root 2 cancels off, then this becomes v over g. So this is the maximum range. So we have the maximum range, if you remember. This angle should be 45 degrees. So we have the radius, then just have to find the area. To find the area, let's apply phi r squared. So it's just 5. R squared is here v squared over g squared. So the value here should be 5 v4 divided by g. So this should be the area that they ask. That is 5 v4 divided by g squared. That is the area of that circle. So the answer for that should be second one. Okay, ninth question. As shown by the image, a light rope which attaches 50 kilogram goes over a smooth pulley. From the other end of rope, a child is climbing maximum acceleration that the child can climb without lifting the mass off the ground is. Okay, so here we have the pulley. Then there's a child, or it could be a monkey. There's a child climbing upwards at an acceleration. So this is 50 kilogram. This mass is 50 kilogram. The mass of the child is 40 kilograms, so the weight of the child should be 400 Newton. Then this causes tension in the rope. The tension at the other side also should be the same because this is a smooth pulley. So what they ask is maximum acceleration that the child can climb, but this mass would start to move upwards. Okay, so this is like a limiting condition. So the maximum acceleration at the maximum value, you have to understand that the normal reaction force acting on this 50 kilogram should be 0. This has a 500 Newton downwards on the mass, but the normal reaction force here should be 0 because at that limiting condition, the child is climbing at the maximum velocity, so maximum acceleration. So this should have the minimum normal reaction force, which is 0 in this case. Okay, they just have to apply Newton's laws to these objects, to the child and to the 50 kilogram. To 50 kilogram, I just apply to 50 kilogram. Upwards T plus R, which is 0, right? Minus 500. This is equal to 0. It is not moving. This is 0. Then T equals 500 Newton. Take 500 to other side. This R is 0. T equals 500 Newton. Then we just found the tension of the rope in this situation. Then apply equation to child. On the child, to upwards there's T, then downwards there's 400 Newton. Then the mass of the child is 40 kilogram. And he has an acceleration symbol A. So that's the maximum acceleration now, right? This becomes max since normal reaction is 0 here. That's a limiting condition. T we just found that is to be 500 minus 400, 40 A max. This is 100, 40 A max. 0, 0 cancels off. 2, 5 divided by 2, 2.5 meters per square second. So this is the maximum acceleration that the child could climb, so the mass won't move upwards. Okay. So the answer for that should be the fourth one for the 9th question. 10th, pulley and a plane are smooth. Pulley is light. When a horizontal force F is applied, acceleration of pulley is. So they have given an image. So there's a pulley here. To the other side, a mass symbol M is attached, and all these surfaces are like smooth. Then on the pulley, there's a force applied, that is capital F. So if this F is applied, you know that symbol M also tends to move to this side, since there's a force acting on the pulley. So what they ask is, in this situation, what should be the acceleration of the pulley? Let's say the acceleration of pulley is simple A. So the key thing that you have to understand is, if the acceleration of pulley is simple A, acceleration of this mass should be 2A. Acceleration of the mass should be twice this acceleration. So if you think about it, just say, if the pulley moves to this side, the length of this, let's say this moves like 1 centimeter to this side, the length difference here becomes 2 centimeters. If it is 1 centimeter, if the pulley moves 1 centimeter to this side, because there's a string at the both side and the same, like parallelly, the string gets shortened by, this string gets shortened by 2 centimeters, because there's a 1 centimeter pulling from here and there's a 1 centimeter moving to this side. Then the total shortening of this part of the string should be 2 centimeters. So meaning that if the acceleration is A here, the acceleration here should be 2A, twice the acceleration. Because the length of this part of the string gets shortened by 2 times as the distance moved by the pulley. So once we get that acceleration, then we just have to apply Newton's laws. Then it is easy. Okay, I will first apply Newton's laws to pulley, to this side. Then we know the tension applied on the pulley to this side, then there's a tension acting on this mass to the other side. So the forces acting on the pulley, that is F to this side minus, there's 2 tension. So this 2T equals mass of the pulley. They say it's a light pulley, so the mass of the pulley is 0. Then the acceleration is equal to A. So F minus 2T equals 0. Then I get an expression for tension. So 2T equals F, meaning tension is capital F over 2. Let's keep that. We'll need that. Then apply equations to mass, simple M. So the forces horizontally acting on simple M are only capital T equals mass. Then the acceleration here should be 2A, not A. Should be 2A. And then earlier we found the tension, that is F over 2. Mass 2A. So what they ask is this one, like acceleration. Then F over the 2 times 2m, if you do cross multiply, this becomes 4m. Okay. So this is F over 4m, that is the acceleration of the pulley. Simple A. We just found it, right? So the answer should be 5th one for the 10th question. 11th question. 2 blocks with mass capital M attached by a light string which goes over a smooth pulley on a wedge as shown by the image. So what they say is what happens here. So this is a simple question, right? At both sides, the mass is the same, but it's a capital M. If the inclination of that side is higher, so the force component along the plane is higher at that side. So it's just think this in practical terms. So it should be A, right? So the capital M should slide down the side A. Slide down the plane. Slide down the plane. A slides down the plane. Slides down from the side A. So that is obvious because that side has the more inclination. You can just prove this using equations, but it is not necessary, right? By just looking at the question, you can answer that. So the answer for that should be first one. An object with mass 2 kg moving to right side at 5 meters per second is submitted to a force 3 Newton to left side for 4 seconds. Velocity gained by the object is. Okay, so we have an object with mass 2 kilogram. So now it is moving to right side at 5 meters per second. But an unbalanced force 3 Newton is applied to the opposite side, left side, that is 3 Newton for 4 seconds. So that is for 4 seconds it is applied. Velocity gained by the object is. So there is an object moving 5 meters per second. So while that is moving, there is a force suddenly applied on the object, that is 3 Newton. So this is just the only force on this one, right? 3 Newton, this unbalanced force. Then that force is applied 4 seconds. There are many ways you can do this, like using the linear motion equations, then apply F equals mv, those stuff. Or the easiest way to do this is apply this one, F equals mv minus mu divided by t. This is just F equals mv, but in like a different form. But here you have to be careful of the signs. I mean, whether something is negative or positive, otherwise you would get a wrong answer here. Be careful of the directions. Okay, I'm applying this equation to this side, right? So all the quantities on this side should be positive. Since the force here is to the other side, this force is a negative, minus 3. mv. Actually what they ask is the final velocity gained. So what they ask is the simple v. Just apply a mass, that is 2 times v minus mu, mass is 2, u is moving to this side, which is a positive direction, right? So that velocity, that is the initial velocity, then it is 5 divided by time is 5. Okay, then just simple calculation to find v. Cross multiply, minus 12 equals 2v minus 10. Minus 10, get to the other side. This becomes minus 2 equals 2v, then v is equal to minus 1 meters per second. So what does this mean? This is minus 1 meters per second. That is to this side, it is minus 1, but to the other side, it should be a positive value. To this side, it is 1 meters per second. Left side, right? So like after 4 seconds, it is moving to left side at 1 meters per second because of this force that happens after 4 seconds. So it should be 1 meters per second to left side. So the answer for that should be the 5th one for the 3rd question. 13th question. Variation of force capital F, which is acted on a mass 5 kg at rest, shown by the graph. Momentum of object after 6 seconds is. So there's a 5 kg of mass at rest. Then a force F is applied on the mass. Then it starts to gain some momentum, right? So what they ask is momentum of the object after 6 seconds. So for the variation of capital F within 6 seconds is given. So the momentum gained by this object should be equal to just the area of this graph. Since that is a FT graph. So value is 2, 6, then this value is 8. This is just a triangle. There's no momentum here. Because initially for 2 seconds the force is 0. But just find. Then this length should be 6 minus 2, that is 4. This length 8. 4 times 8 divided by 2. That is the area of that triangle. 32 divided by 2, that is 16 Newton seconds. So the answer for that should be the first one, 16 newtons per second. 14th question. An object with mass 3 kg moving at velocity v explodes into two parts with mass 1 kg and 2 kg. So mass of the object 3 kg and is moving to this side. Then it explodes into two parts. So this is the after explosion. 1 kg and 2 kg. So they say the large part, that is 2 kg, moves to the same direction. Let's say there is a v over 2. So then what they ask is the velocity of the small part after explosion. Let's take that velocity as u. So for this one, since the momentum is conserved, there's no change of momentum. This applied momentum conservation law. For this one, so the direction, positive direction, this direction, then 3 times v, mv equals 1 times u plus 2 times v over 2. This cancels off. This is just v. Take it to the other side. Then this becomes 3v minus v, 2v equals u. Okay, so this is the velocity of the small part. That is 2v. 2v, right? So the answer for that should be the fourth one. For the 14th, the final question, 15. As shown by the image, a particle with mass 50 gram is sent at 10 meters per second into a tunnel with mass 950 gram. Particle is stuck at B in the tunnel. Given that all the surfaces are smooth, velocity gained by the tunnel is. Okay, that's this. Not a tunnel, let's say like a wooden block or something, but it is on a smooth surface, so there's no friction acting on this. So there's this 50 gram mass. So the mass of this block is 950. So if you think this whole thing to be like a one system, for this system also there cannot be any external forces acting horizontally due to interaction between these two. Okay. So for this as well, we can apply linear momentum conservation. Okay, I'll apply this before this enters into the tunnel and after this enters into the tunnel. So this ball goes inside. Let's say before, the velocity of the ball is 10 meters per second and the mass is 50. You don't have to convert this into kilograms, right? Because both sides have gram. So this is 50 times 10 meters per second. That is mv. Then if this goes into the tunnel, then and it stops here, stuck here, then this whole thing becomes like a one system. Then the mass of the system becomes 950 plus 50. So that is 1000 grams. Because they both start to move at the same velocity, meaning that they became like the same thing, right? Like a compound object. So this is 1000 gram. Then let's say after that the tunnel starts to move at simple v. Initially the tunnel is at rest. Now it gains a velocity v. Then this is a 500 divided by 1000. So that is 0.5 meters per second. 0.5 meters per second is the velocity of the tunnel. So the answer for the 15th question, that should be first one.